Hello everyone, welcome to another Python video. This is the prime factor finder. So the question states that the prime factors of 13,195 are 5, 7, 13, and 29. We're to write a program that can find the prime factors of a number. Okay. So with that said, we're going to determine the largest prime factor for the number that is this big. Let's see. It's 600,851,475,143. Okay, so we're going to find the largest prime factors. Okay, so the solution plan is the following. The tricky thing about this question is that we actually don't need to determine if a factor is prime. We can actually take advantage of how prime numbers work and how factoring works to actually solve this problems. So our solution plan, knowing that the smallest possible prime factor is 2, we're going to continuously divide this number or any given number by 2 if possible, and we're going to shrink down our given input. Okay, then we will know that 2 is a prime factor until we can no longer divide it by 2 and shrink it by 2 by possible. Well, then the next possible prime factor that we could potentially have is 3. So if it's divisible by 3, we're going to continuously divide by 3 over and over and over and over and over again. Okay, and we're going to repeat. And we do this for all odd numbers, okay, because the next number that is going to be divisible is going to be by a prime number if divisible, okay. For example, if we were to divide by a number like 15, the a factor of 5 would have handled that factor by just dividing by 5 by 3 times. So it's nothing to worry about. But what we're going to do is when we set our divider to 3, we're going to increase it by 2 when it's not divisible. Okay, so let's get this program started. So we're going to go num is equal to input, enter a value of n. Since we will be modifying this value, what I'm going to do is just create a copy and set to num. We have these two values nicely initialized. All right, we're going to test 2. I know for this one, 2 can't be a prime factor because it ends with a 3. But here we go. We're going to say while num modulus 2 is equal to 0, we're going to continuously divide that number down. Num is equal to num divided by 2. Since we know that it is a perfect division, we can actually utilize the floor division here to maintain num to be integer. Now, if this was too lengthy, you can obviously write this as num is equal to 2. Okay. Now, we're trying to determine the largest prime factor. So we're actually going to have the largest set to 0. And then since we were able to find a significant prime factor here, we're going to say largest is equal to 2. Okay, but we're going to write this better. We're going to say the following. We're going to say max of largest and comma 2. Basically, what this code is saying is that we're going to take the maximum of what it was prior or 2. So basically, it's going to take 2 because it's 0. But we're going to be utilizing this kind of feature again. Therefore, I just wanted to show you and introduce that right now. So end of while. So in here, we are checking to see if it is divisible by 2. And then continuously shrink it by dividing it by 2. Okay, cool. And at this point, we could reach a value of 1. For example, powers of 2 will just be continuously divided by 2 over and over and over again until it becomes 1. So we can say that if num doesn't equal 1, we still have to check other primes. Okay, so I'm just gonna write pass. All right, and at the end we can say that print f largest is the largest prime factor for, and this is where we're going to use our num copy. If you notice that num is getting affected by our changes in operation, we're actually manipulating it so that we can actually find the largest prime factor. Therefore, I made that copy in the beginning so that when we do our output at the end, we have a nice little output right here. Here we go. So if we're in this situation here, if num is not equal to 1, well, we still have to check other primes. This is where I'm going to introduce a variable called factor, right? I'm going to have other factors that are possible. This here, we check for 2. Now we're going to check for 3. So we're going to say, well, while num modulus factor, actually, sorry. We're going to say, well, while num is greater than doesn't equal to 1. We want to get to 1. So we're going to say, well, we're going to continuously do this while num doesn't equal 1. And what we're going to check is the following. If we have num modulus factor is equal to 0, we have found a prime factor. That means we're going to say largest is going to be updated to copying that code of comparing the previous largest and a value of our current factor. And then since we found a factor, I need to now shrink it down to a new number. So the num is going to be shrunken down by taking the factor value and dividing it. Okay. Now, if we're analyzing this factor variable and it's not a good divisor for our number, that means we have to do the following. We're going to say, well, factor increases by 2. Check the next odd number. Most. It is guaranteed to be a prime if it's guaranteed to be a prime if we were to get in here. So we're to execute the if statement. All right. So if this code executes after increasing by 2, it is guaranteed to be a prime, because otherwise the previous prime factors will take out those odd factors out of our number. Right. So that is it. That is our program. So let's actually test our code. We say Python video solution / vid25.py over 26.py. Okay, and I'm going to copy this code and copy that in. And we get that 6,857 ends up becoming the largest prime factor for our comically large number. So awesome. Thank you for staying through this video. This was a more of a complicated solution because it required you to understand the concepts or know the concepts of prime factors, where you don't need to determine if that number is prime, but rather knowing that if we remove the earlier factors of 2 and removing the earlier factors like 3 and 5, 7, we will be able to really just knock out all the potential odd factors that we can have that are not prime, because the earlier primes will take care of them. All right, so that was our solution. Thank you so much for watching. As always, stay classy.